Hello everyone, I am Indrajyoti Gaine. I was PhD student at Mathematics and Statistics Department of Mathematics and Statistics IIT Kanpur. And presently, I'm a PMRF fellow. Before that, I was getting CSR net and I have cleared my CSR net with 108 rank. So, in the last classes, we have discussed about circle, which is conic section. And after that, we reduced the how we can get the equation of a circle. After that, we have discussed few examples with center at some origin and passing a circle when a circle is passing through some point, and when we can deduce a question of a circle from the given question. All this stuff we have discussed in the last. And after that, we had seen some just some definition of another connection, that is parabola, and how we can get some parabola. We have geometrically we have seen. So in today's lecture, we will go through parabola and we will see how we can deduce the equation of parabola. Okay. So what is a parabola? A parabola is a conic section, and how we can draw this conic section? That is, a parabola is the set of all those points which are equidistant from a fixed point, fixed line, and a fixed point which is not on that line. Okay. So okay, just explaining a little bit today in today's class. So, geometrically speaking, if I have a straight line like this and I have a point like this, then we need to find or we need to find or collect all those points which are equidistant from this point and this straight line, and that must be of the form like this. Okay, and you can see that by due to the definition of this equidistant criteria, we can clearly see that this, if I draw this joining line, then this point, this red point will be the midpoint of line, of this line. Okay, so the red point bisects this black line. Okay, because why is so? Because the distance from this red point of the and from the green point, and the distance from the red point from the line will be same. Okay, so by this we have defined a parabola. So this is the focus. This green point is called focus. This black line is called directrix. Okay, and this red point is called vertex. All this stuff I have discussed in the last lesson. That is what is focus, what is axis, what is directrix, and what is vertex. And after that, we have discussed about four different cases. That is this one case. Another case can be like this. This is the straight line. This is the green point, and this can be the another case. Okay, another case is like this. This is the straight line. This is our green point. This is one case, and another case is like this. This is the another. Okay. Now the thing is, the axis and the directrix vertex. This can be any straight line or any point. Like I can draw a parabola by choosing any fixed line as a directrix and a fixed point outside this line to be vertex. But in general, we are not bothered about those parts. Rather, we are only focused on those cases when the parabola is simplest. That is, the vertex is at the origin, axis is symmetric to axis of symmetry is along the x-axis or y-axis. That is these four cases. Okay, you can see that this axis, whatever this axis is parallel to x-axis in this case, Here also axis is parallel to x-axis. Here the axis is parallel to y-axis. Here also the axis is parallel to y-axis. Fine. And we will focus on this part only. And in this cases, now I want an extra condition, that is this red point will be the origin. This red point will be the origin. Okay. So let us draw it properly. Suppose I am making one case, and other cases you can understand from here. This is our x and y axis. Suppose your x axis, the y. Now this red point is the origin. Okay. I'm not denoting this point due to some clear cut view of the geometrical interpretation. So yeah, you can clearly see that this is the origin. Okay. Now from here, what I need now, I need a fixed point that is drawn in green and a straight line that is drawn in black, which should be opposite to the opposite side, in which direction green point is lying. Green point is lying. Okay. So one more, two more conditions I need, that the red point should be origin, and the green point or the green point should be lying on some axis. Okay. So this is the y-axis, x-axis we have. So either the green point can be at these positions, either this position or this position or this position or this position. This four position can be considered as the position of the focus. Okay. Now for a particular case, I am not considering all those points. I am only considering the green point lies on positive x direction. So where will be the electric? Electric will be opposite to the green point, that is at along the negative y-axis, and it should be perpendicular to the x-axis, that is parallel to y-axis. So this will be line this. Okay. Now we have chosen this green point and black line such a way that this distance and this distance are same. Okay. So denote this distance by a. So what will be the position of this green point? The position of the green point will be a comma 0. And what about the equation of the straight line that is parallel to y axis and perpendicular to x axis? So the equation of the straight line will be x equals to not a, it should be minus. Why minus? Because the straight line is from a at a distance along the negative x. So if this is plus a, then this must be minus. The sign representing the direction of the straight line or this point. Okay, so thus we have obtained a straight line that is called directrix, and a green point that is called the focus. Now we want to find all those points which are equidistant from the straight line and from this focus. Okay, so What will be the question of the question of the parabola then? The equation of the not equation of parabola. How will be the parabola look like? The parabola will look like this. Okay, and just check one thing that from this viewpoint, maybe it's not looking like that it will happen, but the distance from here to here and the distance from here to here, this must be equal. Though by the geometrical some inaccuracy, for the geometrical inaccuracy, the photo looks no, doesn't look like perfect with the parabolic thing, but this should be the fact. A distance from the straight line and a distance from the focus will be always same. So now, if I consider a point P on the parabola, then we need to find the equation of the equation in the form of x and y, so that all the points on this parabola should satisfy that equation. Okay, so how can I find that? So whatever we have, what condition we have, that is the Euler lines are same. And what the Euler line represents? The Euler line represents the distances. Okay. So what will be this line? Like if I denote this point by F, this green point by F, this red point by O, and this black point that is intersecting this uh, parallel perpendicular straight line x equals to minus a and negative x axis at the point M. We are denoting this point by M, F, O, and F. Okay. M, O, and F. Now, whatever we need to find, the distance will be same. So, this distance and this distance will be same. So, by condition, you can say we can say you can say that like P2, we can denote the point by P. This point by PA equals to PB. Now, what is the PA? PA represents the distance from a comma 0 to x comma y. So PF equals to square root of, what is the square root of x minus a whole square plus y square. And what about PB? So any point, if I represent the B point, so any point on this on this directrix has the location like minus a comma y. So y can be variable and y should be dependent on this. So any point which is perpendicular distance from this P point, that must be a perpendicular direction on this directrix. So the y coordinate will not change. That is, you can say this Euler line, this should be parallel to x axis. This Euler line should be parallel to x axis. Therefore, the y coordinate will not get changed. So the coordinate of B should be minus a comma y. Now we can find the distance of PB, and the PB will be x plus a whole square plus 0 square. Why 0 square? Because y minus y could be 0, that is 0 square, which implies x plus a. Fine. Now, according to the condition, we have PF equals to PB. So this implies x minus a whole square plus y square. This is equal to x plus a whole square. Just putting square on both sides. Okay. Then from here, if I express this terms, what I will get x square minus 2ax plus a square plus y square. This is equal to x square plus 2ax plus a square upon x square upon. So ultimately, we are getting y square equals to 4ax. Okay, so that we can deduce the equation of the paragraph. If this now we may get with one another condition like this. So I can make a sub case here and just little bit elaboration will get up to the answer. So I'm drawing the picture. It's a small canvas. This is our origin. In this case, we are considering the point focus will be on negative x-axis. So there will be the point F, which will be F. This is our origin O, and the black line that is the directrix should be at P. So the parabola will be like looking like this. Parabola will look like this. Fine. And this must be the distance should be equal. So all the conditions, whatever we are obtained in this case, those will be equal. So this is distance and the distance must be same. It doesn't look like, but yeah, it will be same. It must be same. It have to be same. Okay. Now, what is the distance between this geometrical integration and this one? So here, f was at the point a comma 0, and directrix was at the point the m point as coordinate minus a comma 0. But in this case, this point m has coordinate a comma 0 and f has coordinate minus a comma 0. And what will be the change in this case? So if I consider any point on this point P as x comma y, and the black point represents the perpendicular line from P to on the directrix P, then that point has coordinate a comma y. So all things will remain similar, just the sign will be get changed. Here a replaced with minus. Okay. So the equation will be, if I replace, so there a will be replaced by minus a. So the equation of the parabola will be minus 4ax. You can deduce also from the same way, whatever we have done here. You can just find the PF and PB cases that you can make the terms equal and making the both sides square and equating all those terms. You can get up to this equation again from the all the calculation. But from the interpretation, you can see that whatever you have done in this case, that is, we have replaced a by minus, right? The focus was a0, that is replaced by minus a0, and the straight line equation to straight line with x equals to plus a, x equals to minus a, and that is replaced by x equals to plus. Here the equation of the straight line is x equals to plus. So this is the difference between these two cases, and you can see how the sign of the coefficient tells about the shape and of the parabola and the direction of the focus, directives, and all the okay. That's why the sign of the parabola must be important. Now another thing is important, that is here you can see both cases we have considered that y square equals to minus 4ax. Okay. So yeah. So y square denotes that this is our x axis, your y axis, y axis. So if the parabola is and like the focus is on the x-axis, in that case the equation will be of the form y square equals to plus minus 4ax. Okay, so just point out this fact. Whenever the focus is, so let me write one plus. Okay, point it. If the focus of the parabola is on the x-axis, then the wing of the form for ax. Okay, so the equation of the parabola will be obtained from y square equals to 4ax. And now the question is, if the focus of the parabola is not on the x-axis, that can rather it can be on the y-axis. So that case we will discuss now. So now the case is our x-axis and this is our y-axis. This is the origin. Suppose this green point represent the focus in this. So if it will be 0 comma a, and the directives will be here, like opposite to the focus, and the equation of the directives will be x, sorry, not x, it will be y equals to minus. Equation of the parabola will be not equation, it will be the graphical representation of the parabola will be like this only. In the distance of any point will be like this, and this two will be equal. This point we can represent as p. This is our b. Your b. So the b has coordinate. If p has coordinate, our p has coordinate like x comma y, then b has coordinate x comma minus. Okay. So in this case, if I again write the equation here, so what is the distance in this case? One is PF and another is PB. So PF equals to PB. Implies x square plus y minus b whole square. This is equals to square root of 0 square y plus a whole square. So this will imply as square root of whole square equals to y plus a. Sorry, I have already taken from something wrong here. Yeah, minus a. This will give us x square plus y square minus 2ay plus a square equals to y square plus 2ay plus a square. Square gone, y square gone, and we will ultimately get x square equals to 2a. Okay. Now you can clearly see if the focus of the parabola is on the y-axis, how the equation of the parabola denotes as effect. Like you can clearly see that the equation of the parabola is replaced by y. The position of the x and y have been replaced, and so the equation also have denoted some significant change that we can just observing on the equation. We can say that yes, this is the equation of the parabola whose focus is on the x-axis, or this is the equation of the parabola whose focus is on the y-axis. Just from here, we can denote this fact, right? And if that thing is like that, we are left with only one diagram, that is this case, right? Okay. So in that case, what will be the case? You can try it yourself, because I have discussed this case for the here and here also. So you just need to replace a by minus. Okay, and that's then only you can find the question of the parabola uh, for the another. And so the standard equation of the parabola will be where the origin is the, you can say origin is the vertex, or what is it? Yeah, the origin is the vertex, and focus and directrix is the, like this. Focusing on the x-axis or y-axis, and directrix will be parallel to x-axis or y-axis. In that cases, the standard equation of the parabola are equation of the parabolas are x and x square 4a. Okay, so these are the standard equation of the parabolas. And clearly, you can see that in this case, the x square and y square, how to denote this thing? X square is, when x square equals to plus 4ay, then the form will be like this, and minus sign will change the direction. And from here, we can say the parabola is symmetric with respect to the axis of the parabola. If the equation of the y square term, then the axis of the symmetry will along the x-axis, and if the equation has the term x square, then axis of symmetry is along the y-axis. From here, we can conclude this fact from this equation and from this equation on. So let's now the definition of the lattice vector. So what is lateral rectum? Before that, first, what is lateral rectum? So lateral rectum is in this parabola. We can say this different color. What we can use? Yeah, green color we can use. This line is called a lateral rectum. This green line passing to the focus is called the lateral rectum. Okay. Now let us the definition of the lateral rectum. Lateral rectum. So lateral rectum of a parabola is a line because the line segment is perpendicular to the axis of the parabola to the focus, and then goes in points line from the line of the parabola. And this is called our lateral rectum. So this green line denoted by this green line in the front becomes show that in our lateral rectum. Now the question is, what is the length of this lateral rectum? Now can you guess from here only what is the length of the lateral rectum only can be? So like I can draw from here a little bit so you can understand properly. This is the and this is the parabola. This is the focus, and this is the directrix concept. Now let us rectum is denoted by a line segment that is passing through the green point, that is the focus, and that will be the perpendicular to the axis. That is perpendicular to the axis means that it will be the parallel to the directrix. You can say that will be parallel to the directrix. To the axis, you can say parallel to the directrix. You can say, and that will obviously intersect the parabola. Or you can the end point will be lie on the parabola. That is the line segment like this. Line segment like this. Now, what is the length? Length means this length. How can find? So this is the focus. Now from here, the distance of this point and the distance from this point will be same by definition of the parabola. Wait. I'm doing it too long. Sorry. Yeah. The distance from here to here and distance from here to here will be same by definition of the parabola. Right? So we can say this distance equals to this distance. and the whole distance will be twice of the distance. Right? Now, what is the how is it? So this point has coordinate. If I write it in a black point, so this point has coordinate minus a to minus a comma some y you can say, and this point has coordinate a comma y, and these two y's must be same. These two y must be same. The distance between them might be 2. Green line will be 2. So this implies this distance must be 2 and this implies the choice of the distance that will be this distance will be 4. Okay? From here we can say length of the system is 4. Then so, so thus we can find length of a ladder system. Now the next point is we can go to some examples. So example 1, the coordinates of the focus axis equation of directives and ladder system of the parabola y square equals to 8. Length of ladder system, you can see. Length of ladder system of the parabola y square equals to 8. So first, just notice that the sign denotes that parabola will be of the form like if this is are the coordinates, if these are the coordinates, the parabola will be of the form like this. This much we can say. Why? Because the equation from the equation we can clearly see that the axis of symmetry will be along the x-axis and the sign represents that the parabola will be of this form and Irish plus. Now it is of the form y square equals to 4ax. Now if we compare these two equations, then we can clearly see comparing these two equations, we can say that 4a equals to 8 which further implies a equals to 2. So the focus will be at this point, focus will be this point, that will be point a comma 0. Now, obviously, the directrix will be at same distance from S focus and in the opposite to the focus. So this directrix will be at this point, and equation of directrix will be what? That will be x equals to minus, right? Now we have a equals to 2. Then the focus is at the point 2 comma 0. focus is at the point 2 comma 0. Okay. Directrix has equation x equals to minus, and length of lateral sectum will be length of lateral sectum will be 4a, and 4a means 4 into 2, that is equals to 8 in this case. Okay. So the length of the left will be 8 here. And what is the left width? That is the axis. You can clearly see the axis is along the axis of symmetry. You can say the axis means axis of symmetry, and that is the positive x-axis you can see. So you can say just x-axis is enough. You can see. Okay. Now, depending upon this side, you can say the parabola opens at right or left. So first decide that the parabola opens in which direction, either it is right or left. And if it is a equation like x square plus 4ay, then the parabola opens at the top or bottom. You need to first figure out by watching the side. After that, you can go that what is the focus, what is the directrix, and what is the all your terms you make. Okay. So example 1 is done. What about example 2? Find the equation of the parabola with focus 2 comma 0 and directrix is equal to minus. Find equation of the parabola with focus of 2.0 and 2 comma 0 and directrix at x equals to minus. So first draw the geometrical figure. The focus is at the point 2 comma 0. See the parabola. Why this is will be a parabola? Because we can clearly see from the equation of the directrix and position of the focus that this will be the case. This will be the case. Now, what we need to find the equation? How can find? So we know this kind of equation will be of the form like y square equals to 4x. Okay, this kind of parabola looks like y square equals to 4ax, and here a is 2. So this will be nothing but y square equals to 8. Now, at this point, if someone don't know, or maybe he or she may get forget that how the equation of this kind of figure looks like, and he may get confused about that the sign of the parabola, that either it is y square equals to 4ax or minus 4ax, or either it is x square equals to 4ay or minus 4a. He may get confused because this is the first time for their something, so he may get confused. So for that case, you can try that whatever we have done, how we have reduced the equation of the parabola here, you can follow that path on. How? Just consider a point on this parabola, you can say that the parabola is the collection of all the points x, y, x comma y, and just find the distance of that point x to y of from the point F and from the point on the line x equals to minus. Then you can find the equation of the parabola. It may take some time, extra time, the exam will be difficult, but yeah, you can figure out, at least you can figure it. But here only if you can recall the fact that this is the equation, this must be the equation, then you can just put the value of A and you can get the solution of the you can say you can get the equation of the parabola easily. It's just in this one. So let's go to example 3. Find the equation of the parabola which is symmetric about the y-axis and passes through the point 2 comma minus. Find the equation of the parabola which is about the y-axis and passes to the point 2 comma 3, 2 comma minus. So here they didn't give any focus or equation of directrix or anything, but they have mentioned some criteria of the parabola statistic. Okay. So the first is that the equation of parabola which is symmetric about the y-axis. So first denote what is x to y-axis. So it is saying is about x-axis, this is about y-axis. So it is saying that the equation of parabola is a certain that's symmetric about the y-axis. Right? So two ways may arise. Either it is of the form like this, or it can be a case like this. That much we can guess that either the equation are geometrically, you can say the parabola will be like either in the first row or in the second. Now we need to figure out that which one is the correct. For that, we can clearly see the second condition, that is the parabola will pass through the point 2 comma minus. The 2 comma minus means x coordinate is positive and y coordinate is negative. So x positive, y negative, that means the parabola should be the point should be at the fourth coordinate. Point is at some point like x 2, 1, 2, 3. So here it can be some at some point here. Now if we consider a parabola of the form like this, then this parabola doesn't contain this point. It is impossible for this contain this point for this parabola. So obviously the parabola will be of the form like this. Hence, the equation of the parabola will be of the form x square equals to minus 4ay. Now, at this point, I don't know the value of a till now. Right? We need to figure out. For that, we can put the value 2 comma minus 3 in this equation. So what we will get? we work x equals to x equals to 2 and y equals to minus 3, then what I will get in square equals to minus 4 into a into minus 3. Okay, this will give us 4 equals to 12a, that is a equals to 1 by 3. So putting this a equals to 1 by 3, we can get the equation of the parabola is x squared equals to minus 4 by 3, or you can say 3 square equals to minus 4. 3 square equals to minus 4y. So this is the equation of the parabola. And here you can clearly see that they haven't mentioned anything about the focus or directrix of the case of the parabola, even though they have given some condition how we can guess that how the equation will look like, and about we have studied the point for through with the parabola test through, and by that we have generated the equation of the parabola. Right? So yeah, that's we can find the equation of the parabola. Okay. The last two. Yes. Another example you can try. Easily you can try that. Same example, if I apply the point like this, so yeah. So exercise of symmetry. We don't need to go to that question again. Similar to this question. Question is this. Let me three. Find the equation of the parabola with vertex at 0, 0 and focus at minus 3, 0. Minus 3, 0. Okay. So just first identify the points. So they are saying the vertex at the point origin. The vertex means which one? Just recall. Yeah. This point at the point origin, we are already discussing that point one. Only we discussed that point, those is only. So vertex at this point and focus at the point minus 3, 3. What 0? Yeah. Okay. Now, how will the equation look like? So you don't know in this case the equation of the directrix, but you also know the equation of the directrix. How? See, they have given the location of the focus, that is minus 3, 0. So the directrix will be in opposite direction, in opposite side, and that will be just at same direction, at same distance as of this minus 3 comma 0, right? So the equation of the directrix will be the form like x equals to t. Perfect. So the equation of the parabola will be, so if they didn't mention about the directrix equation about directrix, this equation, this term we don't need it. If we know the focus is at the point 2 comma 0, that is sufficient to understand that the directrix is at the point. Okay, if they have given these two conditions, that is fine. But if they given that the focus is at the origin, that is the vertex is at the point origin, then we don't need condition, that is directrix at the point x comma minus 2, x equals to minus 2. Okay, the directrix at the point x minus 2 indirectly implies that the vertex is at the point origin, because you can see the vertex is the only point which is bisecting the line joining 2 comma 0 and the directrix. Okay, so in this case the equation of the parabola will be look like this. The parabola will look like this, the equation, and obviously the parabola equation of the parabola will be look like of the form y square equals to minus 4a x power, yeah, like it's minus equals to 3. So the equation will be of the form x into 3 into x. Now one may get confused at this point that why I have put a equals to 3 instead of minus 3. Okay. So you shouldn't get confused, because this is the form of the equation with this. This is the form of the equation of the parabola of which look like this. But here equals to 3. Why I put it equals to 3? Because in this equation, whenever we have obtained the equation of the form y square equals to 4ax, yeah, here we have obtained y square equals to 4ax, and we have replaced a by minus a here, and we obtain this equation here. So for minus a, we obtain the equation like this. So what will be the a? A will be obviously 3, right? So this should be like minus a comma 0. If I compare minus a equals to minus 3, this will imply as a equals to 3. That's why we will put a equals to 3 in this equation, and we obtain the equation of the parabola. Okay? So don't get confused that why I have put a equals to 3 instead of minus. So yeah, this much is you need to know about parabola. So in the next day we will go on in the another Conic section, that is ellipse, and after that we will discuss some more questions about all this Conic section for better understanding. Okay, I am finishing at this point. Right?